This is Joe narrating a PowerPoint in Science, the unit in Scientific Practices, Lesson 5, Use Statistics and Probability. This is found on page 500 in the Kaplan book. This is very much a repeat of the lessons that you learned in math on combinations, permutations, and probability. For example, you can refer to page 298 through pages 306 to get everything that's in this lesson in science. But we'll do a quick review of probability, combinations, and permutations. And also measures of central tendency, like mean, median, mode, and range. So the mean is the average. To find the mean of a set of numbers, you take the sum of the numbers, meaning you add them all together, and then divide by the number of numbers. So if you have the data set in pink towards the bottom of this slide on the left, 2, 2, 3, 5, 5, 7, 8, you have 7 numbers. You add them all up and you get 32. You divide by the number of numbers, which is 7, and your average will be 4.57. The median is the number in the middle when you place the numbers in order from lowest to highest. If there's an odd number of numbers, like in our set of numbers down below, you just take the number that's in the middle. 5 is the number in the middle. There's 3 to the left of 5 and 3 to the right of that first 5. If there's an even number of numbers, you take the 2 middle numbers and take their average. The mode is the number that appears most often. In our set of numbers, 2 appears twice, 5 appears twice. The other numbers, 3, 7, and 8, appear once. So this set of numbers has 2 modes, 2 and 5. The range of a set of numbers is the difference between the lowest and the highest value. The lowest value is 2, the highest value is 8, so the range is 6. So we use mean, median, mode, and range to get an idea of what a set of numbers looks like. For example, if I say that the median height in a classroom is 5 feet 6 inches tall, and it varies from 3 feet to 9 feet, that's a totally different group of people than if I say the height is 5 feet 6 inches tall on average, and the group ranges from 5 feet 4 inches to 5 feet 8 inches. In the second group, people will be almost all the same height. In the first group, where you had a range from 3 feet to 9 feet, there's quite remarkable differences between the members of the group. So here's a review slide. You can hit pause and just make sure you understand all these ideas. Probabilities will show up on the math test and the science test. So the probability of something is just a chance of that designated event occurring. So it's always a number between 0 and 1. You can describe it in terms of a percent, a fraction, a ratio, or a decimal number between 0 and 1. So for example, the chance of getting heads on a coin flip can be described as 50%, 1/2, 50-50, or 0.5. 0 probability means that there's no chance of the designated event happening. A probability of 1 means that it's absolutely certain that the designated event is going to happen. And we'll talk about the difference between independent and dependent events. Independent events are when what happens on the first event has no effect on what happens on the second event. For example, if you toss a coin and then roll a number cube or a die, what happens on the coin toss does not affect what happens when you roll the die. Dependent events are when what happens on the first thing you do, that outcome affects the probabilities in the second event you're going to do. And we'll talk about that. So independent events. So you have a set of tiles with different letters on them, and then you have a spinner with an arrow pointing towards different letters. There's seven different tiles, and there's 6 different letters on the spinner. So the question is, one letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? Now the vowels include the letters A, E, I, O, and U. So in the tiles, the letters E and A are both vowels, so that there's two designated events that could happen, E and A, and there are 7 total, so the chance of selecting a vowel is the number of successes, which is 2, divided by the number of total tiles, which is 7. On the spinner, the chance of getting a vowel is either an A or E is considered a success, so the chance of getting an A or an E is 2, and there's 6 total letters, so the probability is 2 over 6, or 1/3. When you have independent events, you multiply the 2 probabilities in each event to get the total probability. So we multiply 2 out of 7, the probability of getting a vowel on the tiles, times 1 out of 3, which is the probability of getting a vowel on the spinner, and we use our rules of multiplication to get 2 over 21. Dependent events are when what happens on the first time you do something affects what happens on the second time. So for example, a bag contains 4 blue chips, 4 red chips, and 2 green chips. A chip is selected and not replaced. Another chip is then chosen. Find the P of getting 2 greens. P stands for probability of getting 2 greens. So on the first draw, there are 2 green chips which would be considered successes. Either one is considered a success. So there's 2 successful outcomes and there's 10 total chips. So the probability that the first chip is green is 2 over 10. We don't replace that green chip, so the second time we draw, there are only 9 chips left and there's only 1 green chip left. So the probability of getting a green chip the second draw is 1 over 9. So again, for the 2 consecutive events, we multiply the probability of each event, and we get 2 over 10 times 1 out of 9, and they mathematically they just change the 2 over 10 to 1 out of 5, its equivalent fraction, and they get 1 out of 45. So the probability of choosing 2 green chips is 1 in 45. We're going to do a quick review of combinations and permutations. So your book on page 304 talks about combinations with more than one type of item and how you can combine them. For example, if a meal at a restaurant includes a meat dish, a vegetable dish, and bread, and you have 3 different types of meat, 5 different types of vegetables, and 2 different types of bread, how many different meal combinations are possible? So all you do in this situation is multiply the number of possible meats times the number of possible vegetables times the number of possible breads, and you get 30 different combinations. You could set up a chart like they started to draw on this slide. You have meats, you have either A, B, or C. For each meat, you have 5 different vegetables in green, and for each vegetable, you have 2 different breads. So you can see that for each vegetable, there's 2 breads, and for each meat, there's 5 different vegetables, and that's why you multiply them all together. So you can do a tree diagram or just multiply the number of each item. Another type of combination problem you'll see is when you have combinations of just one type of item. For example, if you have 31 different ice creams, how many possible 3-scoop combinations could you create? So you can draw a diagram for this, as they do in the book, and most GED problems could be solved with doing a diagram like they do on page 302 in the Kaplan book. But another way is to use a formula. This formula is not given on the GED test, but basically it says that in the equation down below, if you have 31 different items and you're combining, that's what the C stands for, 3 of them, then you have this formula that says that the number of combination is 31, that exclamation point is pronounced factorial. 31 factorial, which is the total number of items you have, divided by 3 factorial, which is the number of items that you're going to select, and then parentheses the difference between the number and that you started with and the number in the combination, 31 minus 3 factorial. So 31 factorial is just 31 times 30 times 29 times 28 all the way down to 1. 3 factorial is 3 times 2 times 1. And 31 minus 3 is 28 and then you put the exclamation point and you pronounce it 28 factorial. In most of these problems you'll see that there's going to be a cancellation of in the numerator and denominator. The 28 factorial will cancel out top and bottom, and you'll be left with 31 times 5 times 29, because 30 divided by 3 times 2 times 1 is 5, and you get 4,495. So that's a lot of different combinations, and that's why the formula might be helpful to remember. You could do this, as I said, by a chart. Either way works. Permutation is an ordered arrangement of objects without allowing repetitions among the objects. So the order matters in permutation. So find the number of permutations in each situation. A softball coach chooses the first, second, and third batters for a team of 10 players. The easiest way to do permutation problems is to just reason how many different players could be the first batter. If you have 10, there could be 10 different batters batting first. If that batter is fixed in place in the first place, how many batters can be second? There can be 9 batters in the second position. If those first 2 positions are fixed, how many can be in the third position? That's 8. So your total number of permutations is 10 times 9 times 8, or 720. In example B, 3-digit numbers are formed from the digits 2, 3, 4, and 5 with no digits repeated. Obviously, the order of numbers, the order of the digits matters to pick a number. So how many different digits can be in the first place? You can have 4 different ones in the first place. Once that is set, there's 3 different ones for the second place. Once that is set, there's 2 different ones for the third place. So it's 4 times 3 is 12 times 2 is 24. So you can have 24 different 3-digit numbers formed from the numbers 2, 3, 4, and 5.